The James Webb Space Telescope, JWST, has changed the way we see the universe, opening up new realms of understanding about distant galaxies, the early universe, and even our own solar system. Among its many astonishing discoveries, one of the most exciting and eye-catching revelations is its brand-new, unprecedented images of Saturn. These images, particularly of the gas giant's famous rings, have captured the attention of scientists and space enthusiasts alike, offering insights into Saturn that have never been seen before. The JWST's infrared imaging capabilities have provided a detailed look at Saturn's rings and its atmosphere, revealing previously unknown aspects of the planet's structure and behavior. For years, Saturn's rings were the subject of intense speculation, with scientists long wondering what secrets they might be hiding. Thanks to the JWST, some of those mysteries are finally beginning to unfold. Saturn has always been one of the most iconic planets in our solar system. With its bright, shining rings, it has captured humanity's imagination for centuries. Observations from telescopes like the Hubble Space Telescope and space probes such as Cassini have allowed us to observe Saturn in great detail. However, even with all of the images, data, and discoveries made by these earlier missions, there was still a sense that we were missing something. Saturn's ring system, for example, remained an enigma. Although we knew that Saturn's rings were made up of countless particles of ice and rock, many of the finer details about their formation, evolution, and current state remained unclear. The JWST's new images have provided a fresh, deep look at the rings, revealing hidden features that could shed light on the planet's past, its future, and the dynamic processes occurring within its ring system. Saturn's rings were originally thought to be a single, uniform structure. But as more spacecraft made their way to Saturn, it became clear that the rings were much more complex. They are not a monolithic structure but are composed of multiple, individual rings, each with its own unique characteristics. Some of these rings are made of small ice and dust particles, likely remnants from the early solar system. Other rings seem to have formed more recently, possibly as a result of the destruction of moons or the collision of asteroids. Enceladus, one of Saturn's moons, has played a significant role in the formation of Saturn's rings. Enceladus regularly shoots jets of ice and water vapor into space, and these icy plumes contribute to the formation of the planet's outer rings. This process shows that Saturn's rings are not a static feature but are part of a dynamic, evolving system driven by both internal and external forces. The infrared capabilities of the JWST have allowed scientists to observe Saturn's rings in incredible detail. In the new images, the rings appear as thick, bright bands with a snowy sheen, clearly visible against the dark background of Saturn's atmosphere. This bright glow is caused by the reflection of infrared light off the ice and rock particles in the rings. The level of detail that the JWST provides is unlike anything we've seen before, allowing researchers to better understand the composition and structure of Saturn's rings. In fact, the new images might help solve a century-old mystery about the rings' age and how they formed. The JWST has made it possible for scientists to explore the rings' finer features, such as the density and distribution of the particles, and to examine how the rings are interacting with Saturn's moons, its atmosphere, and its magnetic field. This new data could answer key questions about Saturn's rings that have been puzzling astronomers for decades. Not only do the JWST's infrared images provide a new perspective on Saturn's rings, but they also offer a deeper look at the planet itself. Unlike other telescopes that primarily capture visible light, the JWST specializes in infrared observations, which allows it to see through Saturn's thick cloud cover. This ability to capture infrared light has given scientists a fresh view of Saturn's atmosphere, revealing details about its composition and the processes that occur within it. The new images show Saturn as a dark sphere, with warm orange and brown tones that contrast sharply with the bright, well-known images we typically associate with the planet. This appearance is a result of the infrared light, which penetrates through the clouds and allows us to see deeper into Saturn's atmosphere. In these new images, researchers can study the distribution and behavior of methane gas in Saturn's atmosphere. Methane, the third most abundant gas in Saturn's atmosphere, is a key component of the planet's climate and weather patterns. One of the most intriguing aspects of the new JWST images is the presence of two dark spots on Saturn's surface. These dark areas correspond to regions where methane gas is particularly concentrated. The ability to identify these spots with such precision provides scientists with a new tool for understanding the behavior of methane in Saturn's atmosphere. This information could be crucial for understanding Saturn's weather patterns, seasonal changes, and the complex dynamics that govern the planet's climate. Methane is a particularly interesting component of Saturn's atmosphere because it absorbs infrared light at specific wavelengths. As a result, areas with high concentrations of methane appear darker in the JWST images, allowing scientists to map out the distribution of this gas with incredible accuracy. The study of methane absorption in Saturn's atmosphere is one of the primary goals of this new round of observations. Researchers are eager to understand how methane behaves on Saturn and whether it might play a role in the planet's unique weather phenomena. In addition to methane, the JWST images provide new data on other atmospheric components, such as aerosol particles and various ionized gases. These observations could help us better understand Saturn's weather cycles, the composition of its clouds, and how its atmosphere interacts with its moons and ring system. The JWST's observations of Saturn come at a time when the planet's seasonal changes are particularly important. Saturn's long orbit around the Sun means that its seasons last much longer than those on Earth. A single Saturnian year lasts almost 30 Earth years, meaning that each of Saturn's 4 seasons lasts for more than 7 Earth years. This extended seasonal cycle means that Saturn experiences dramatic shifts in its weather patterns over time. In particular, Saturn's northern hemisphere is currently in the final stages of its 7-year-long summer. As a result, the northern hemisphere is experiencing extreme weather conditions, including massive storms and unusual atmospheric phenomena. The JWST's infrared images are helping scientists monitor these changes in real time, providing valuable data about the planet's long-term weather patterns and the role that seasonal shifts play in shaping Saturn's atmosphere. One of the most exciting aspects of the JWST's Saturn observations is its potential to provide new insights into the planet's internal structure. While we can observe Saturn's atmosphere and surface in great detail, much less is known about what lies beneath. Like Jupiter, Saturn is thought to be composed mainly of gas, with a small, dense core at its center. However, this model is based on limited data, and some scientists believe that there may be more to Saturn's internal structure than we currently understand. The new images captured by the JWST could provide crucial data for testing our theories about Saturn's interior. By analyzing the planet's atmospheric patterns, temperature gradients, and methane distribution, scientists hope to learn more about the structure of Saturn's core and whether there are any surprises hidden beneath its thick layers of gas and clouds. While Saturn itself is a fascinating subject of study, the JWST has also provided new insights into the moons that orbit the planet. Saturn is home to more than 140 moons, and several of these moons have intriguing features that make them prime targets for future exploration. In its new images, the JWST was able to capture 3 of Saturn's moons, Enceladus, Dione, and Tethys. Enceladus, in particular, is one of the most exciting moons in our solar system due to its active water geysers and potential for harboring life. Enceladus regularly expels plumes of water vapor, ice particles, and organic compounds into space, suggesting that beneath its icy surface, there may be a subsurface ocean. This makes Enceladus one of the most promising places to search for signs of extraterrestrial life. In addition to Enceladus, the JWST images also show Dione and Tethys, 2 other moons that have sparked the interest of scientists. Dione is a medium-sized moon with a diameter of around 1,120 kilometers, making it slightly larger than Enceladus. Tethys, on the other hand, is slightly smaller than Dione, with a diameter of about 1,060 kilometers. Both moons have icy surfaces, and scientists believe they may have hidden geological features that are worth studying. The JWST's infrared observations of these moons could provide new data on their composition, surface features, and internal structure, which could help guide future exploration missions. Of course, Saturn is not the only planet in our solar system to benefit from the JWST's infrared capabilities. The telescope has also captured stunning images of other gas giants, such as Jupiter, Uranus, and Neptune. These planets, while well known in their own right, appear completely different in the infrared images captured by the JWST. The vibrant colors and intricate details revealed by the JWST show us a new side of these planets, offering a deeper understanding of their atmospheres, weather patterns, and ring systems. The infrared observations of Jupiter, for example, show the planet's famous Great Red Spot in unprecedented detail, allowing scientists to study the storm's structure and behavior in ways that were never before possible. Similarly, the JWST's observations of Uranus and Neptune reveal new features of their faint ring systems, as well as previously unseen details about their complex atmospheric processes. In conclusion, the James Webb Space Telescope has revolutionized our understanding of the solar system, particularly Saturn and its complex ring system. The infrared images it has captured provide insights into the planet's weather patterns, atmospheric composition, and internal structure, while also revealing hidden features of its moons and rings. The discoveries made by the JWST are just the beginning, and scientists are eager to continue analyzing the data to learn even more about Saturn and the other gas giants in our solar system. With each new image, we are reminded of how much there is still to discover about the planets in our own backyard. As the JWST continues its mission, we can look forward to even more stunning revelations that will push the boundaries of our knowledge and reshape our understanding of the universe.